Assalamu alaikum everyone. Hope you all are doing well. In this video I am going to discuss the most important topic, that is isotopes. Some of the quite confusing concepts related to this topic will also be overviewed in detail in this video. Now just start from the term isotope. So what are isotopes? This term is basically coined from the Greek word, that is iso means same and topos means place. Simply we can say that atoms having the same number of protons but different number of neutrons are called isotopes. This in turn means that atoms having same atomic numbers but different atomic masses are known as isotopes. For further clarification, we will discuss the example of isotopes of hydrogen. The simplest element of the periodic table, hydrogen, has three isotopes: protium, deuterium, and tritium. Another most important point to consider here is the representation of these isotopes. Just look carefully upon the slide. On left hand side of the symbol of the elements, we will place atomic numbers as subscript and atomic mass as superscript of the element. Now let's discuss the isotopes of hydrogen. The first isotope of hydrogen, protium, is the most abundant isotope of hydrogen on Earth. It has atomic mass of 1. What does it mean? It means that it has 1 proton and no neutrons in the nucleus. The second isotope of hydrogen, deuterium, has atomic mass of 2, which simply means it has 1 proton and 1 neutron in the nucleus. Similarly, the third isotope of hydrogen, tritium, with atomic mass of 3, has 1 proton and 2 neutrons in its nucleus. Now we will learn about atomic masses of atoms. As we all know that atom is very small entity and cannot be weighed on gram or kilogram scales. This fact made scientists to develop atomic mass unit to think about mass on atomic or molecular scale. Atomic mass unit can be represented by AMU or simply mu. Now what is AMU? It is the 1/12 of the mass of most common isotope of carbon, that is carbon 12. In order to differentiate the mass in kilograms and mass in atomic mass units, we will look upon the masses of subatomic particles. This table represents the mass in kilogram and mass in atomic mass units of protons, neutrons, and electrons. Now, what you can conclude from the table? As it is clear from the table that atomic mass unit made the masses of these subatomic particles more clear and comprehensive. Moreover, it is easier to compare the atomic mass of subatomic particles in AMU scale as compared to in kilogram scale. This also clears that the mass of electron is so small, nearly 2000 times than that of proton and neutron, that it can be neglected. Due to this reason, atomic mass of an atom comprises of protons and neutrons and not electrons. Now, as it is clear what is atomic mass in different scales and what is its significance, we will move towards average atomic mass. This is the mass mostly mentioned in the periodic tables. Before heading towards this term, I will first introduce you to the relative abundance. Different isotopes have different relative abundances, which means that some isotopes are more naturally abundant on Earth than others. If we consider the isotopes of hydrogen, protium is the most abundant isotope of hydrogen with a natural abundance of more than 99.98% with 1.007825 AMU. While deuterium is also the stable isotope with natural abundance of about 0.0156%. The third isotope, tritium, is radioactive and unstable. It is extremely rare on Earth. Now this is the time to learn about the calculation of average atomic masses. It is simply the sum of product of atomic mass of each isotope of that element with its relative abundance. For further clarity, we will discuss the example of hydrogen. As everyone knows, hydrogen has two stable isotopes, that is protium and deuterium. We will simply add the product of atomic mass of both of these isotopes with their relative abundance, and it came out to be 1.00784. Also notice that the relative abundance of protium isotope is very high, therefore the value of relative atomic mass is more closely related to protium. This was all about isotopes and related concepts of their masses and natural abundances. Hope you all get maximum from it. Next video will be on the determination of natural abundances of isotopes with the help of mass spectrometry. If you guys have any questions or want any video on some specific topic, do mention in the comment section below. Stay blessed. Allah Hafiz.